The Accidental Masterpieces: How Science Learned to Listen to Mistakes. Chance favors the prepared mind. Louis Pasteur. History loves a simple story. A brilliant scientist studies a difficult problem for years. An inventor works late into the night. Then comes a sudden flash of insight, a triumphant cry of eureka, and the world is forever changed. It is an inspiring story. It just isn't always true. Many of humanity's greatest breakthroughs did not begin with perfect planning. They began with spilled chemicals, contaminated petri dishes, strange noises, broken equipment, forgotten experiments, and results that looked, at first glance, like failures. Every day, laboratories around the world produce mistakes. Most are quickly discarded, their causes explained and forgotten. Yet every so often, one unexpected observation refuses to disappear. Instead of throwing it away, a curious scientist pauses and asks a simple question: why did this happen? That question has saved millions of lives, transformed everyday living, and even reshaped our understanding of the universe. These discoveries were not miracles of luck alone. They were moments when prepared minds recognized that an apparent mistake might be trying to tell them something. Perhaps the greatest masterpieces of science are not planned at all. Perhaps they begin as whispers. The mold that saved the world. In September 1928, Scottish bacteriologist Alexander Fleming returned to his laboratory after a holiday. One of his petri dishes had been contaminated by mold. To most scientists, the experiment had failed. The proper response would have been obvious: throw it away. But Fleming noticed something peculiar. Around the invading mold was a perfectly clear ring, where bacteria refused to grow. Whatever the mold was producing seemed to destroy the bacteria. Instead of discarding the dish, he investigated it. That small decision eventually led to the discovery of penicillin, the world's first widely successful antibiotic. Diseases that had claimed countless lives, including pneumonia, blood poisoning, and infected wounds, could suddenly be treated. Modern medicine entered an entirely new age. Yet the story did not end with Fleming. His observation was only the beginning. Turning penicillin into a practical medicine required years of painstaking work by Howard Florey, Ernst Chain, and dozens of researchers who learned how to isolate, purify, manufacture, and test the drug during World War II. Chance opened the door. Science walked through it. The whisper from the beginning of time. Some accidents happen under a microscope. Others echo across the universe. In 1964, radio astronomers Arno Penzias and Robert Wilson were trying to eliminate an irritating background hiss from a giant Bell Labs antenna. They checked every wire. They tested every circuit. They even climbed inside the antenna to remove pigeon droppings, suspecting birds had contaminated the equipment. Still, the mysterious noise remained. Eventually, they realized that the signal was not a malfunction at all. It was the faint microwave radiation left over from the birth of the universe itself, the cosmic microwave background, the ancient afterglow of the Big Bang. But once again, the discovery was not luck alone. The significance of the signal depended on theoretical physicists who had already predicted that such radiation should exist. If the Big Bang theory was correct, observation and theory met at exactly the right moment. The universe had been quietly whispering its history. For nearly 14 billion years, someone finally understood what it was saying. Seeing the invisible. In 1895, German physicist Wilhelm Conrad Röntgen was experimenting with cathode rays in a darkened laboratory. Suddenly, a fluorescent screen several feet away began to glow. That should not have happened. Curious, Röntgen began placing different objects between the mysterious rays and the screen. Finally, he placed his own hand in front of it. He could see the outline of his bones. Within weeks, physicians across Europe were using what Röntgen called X-rays to look inside the human body without making a single incision. Today, X-ray technology is used not only in hospitals, but also in airport security, engineering, archaeology, and manufacturing. An unexpected glow opened an invisible world. From the laboratory to everyday life. Not every accidental masterpiece changed hospitals or astronomy. Some quietly changed ordinary life. Often these inventions were born not from scientific breakthroughs, but from practical curiosity. They remind us that discovery is not confined to laboratories. It can happen anywhere someone pays attention. A candy bar that changed the kitchen. During World War II, engineer Percy Spencer was testing radar equipment when he noticed something odd. The chocolate bar in his pocket had melted. Rather than dismissing the incident, Spencer wondered whether the radar's magnetron had produced the heat. He experimented with popcorn kernels. They popped. Then he tried an egg. It exploded. Within a few years, the first microwave oven appeared. Today, millions of kitchens rely on an invention, inspired by nothing more dramatic than a melted candy bar. A medicine looking for the wrong disease. Sometimes failure simply means asking the wrong question. In the 1990s, researchers at Pfizer were developing a medication to treat heart disease and chest pain. The results were disappointing. The drug was not performing as expected. But participants in the clinical trial consistently reported one unexpected side effect. Researchers paid attention. Instead of abandoning the compound, they investigated its surprising effect. The result was Viagra, one of the most successful medicines ever developed. The original experiment failed. The observation succeeded. The glue that wasn't a failure. In 1968, chemist Spencer Silver was assigned to create an exceptionally strong adhesive for 3M. Instead, he produced one that barely stuck. It seemed completely useless. For years, no one knew what to do with it. Then another 3M scientist, Art Fry, became frustrated because paper bookmarks kept falling out of his church hymnal. He remembered Silver's unusual adhesive. The failed glue became the Post-it note, one of the world's most recognizable office supplies. Sometimes an invention spends years waiting for someone to discover the problem it was meant to solve. Nature's tiny hooks. Not every lesson comes from chemistry. Sometimes nature has already solved the problem. In 1941, Swiss engineer Georges de Mestral returned from a walk with his dog covered in burrs. Annoyed, he examined one under a microscope. Each tiny burr was covered with microscopic hooks that clung perfectly to loops of fabric and fur. Nature had invented an elegant fastening system long before humans. De Mestral copied it. The result became Velcro, now used in clothing, medicine, aviation, and even space exploration. A blue no one meant to paint. Even today, science continues to surprise itself. In 2009, chemist Ma Subramanian and his team at Oregon State University were researching new electronic materials. They were not searching for a pigment. Instead, one experiment unexpectedly produced a brilliant, intensely stable blue. Unlike any previously known, the new pigment, now called YNMN blue, proved remarkably durable, non-toxic, and capable of reflecting infrared heat, making it useful in paints, buildings, and artistic materials. More than a century after penicillin and X-rays, science was still discovering accidental masterpieces. More than happy accidents. Looking across these stories, a remarkable pattern begins to emerge. A mold contaminates a culture dish. A radio antenna hears an unexplained hiss. A fluorescent screen glows unexpectedly. A chocolate bar melts. An adhesive refuses to stick. A clinical trial produces the wrong result. A strange blue powder appears in a furnace. At first, these events seem completely unrelated, but they all reveal the same truth. None of these discoveries happen simply because someone was lucky. Millions of contaminated dishes have been discarded. Millions of odd measurements have been ignored. Millions of experiments have produced unexpected results. Luck may provide the clue. It never completes the discovery. What transforms an accident into a scientific breakthrough is careful observation, disciplined investigation, repeated testing, and the willingness to question assumptions. Unexpected results become meaningful. Only when researchers pursue them with patience and rigor. Louis Pasteur understood this better than anyone when he observed, "Chance favors the prepared mind." A prepared mind recognizes that an anomaly is not necessarily an error. Sometimes it is evidence that nature is trying to teach us something new. Listening to the unexpected. Modern science has learned this lesson well. Researchers no longer rely on fortunate accidents alone. They have built entire systems designed to detect the unexpected. Artificial intelligence now analyzes millions of medical images, searching for subtle patterns that human eyes may overlook. Particle physicists sift through unimaginable amounts of data from the Large Hadron Collider, looking for events that refuse to fit existing theories. Astronomers use sophisticated algorithms to search billions of stars for tiny irregularities that may reveal new planets or previously unknown cosmic phenomena. In many ways, modern science has become remarkably systematic about investigating surprises. Scientists understand that the most valuable data point is sometimes the one that does not belong. An unexplained signal may reveal a new particle. An unexpected mutation may lead to a life-saving therapy. An unusual chemical reaction may create an entirely new material. Of course, most anomalies turn out to be ordinary mistakes. But history has taught scientists something important. The experiment that refuses to behave is often the one worth examining most carefully. Rather than asking only, "How do we eliminate this error?" today's researchers often ask a second question: what if it isn't an error at all? That shift in thinking may be one of the greatest scientific discoveries ever made. Conclusion: the accidental masterpieces of science are not really stories about accidents. They are stories about attention. History remembers the mold in Fleming's laboratory, the mysterious hiss in a radio antenna, the glow of an unseen ray, and the chocolate bar that melted in an engineer's pocket. Yet none of those moments changed the world by themselves. They mattered because curious minds refused to look away. Science has learned one of its greatest lessons from its own surprises. Sometimes the most important discovery is not the answer you were seeking, but the unexpected question that asks you to begin again.
It's time to study new words in context. 1. Breakthrough. Definition: an important discovery or achievement that solves a problem or changes something in a big way. Example: the new medicine was a breakthrough in the fight against cancer. 2. Petri. Definition: a petri dish is a small, round, flat dish used by scientists to grow bacteria or other tiny living things. Example: the scientist placed bacteria in a petri dish for the experiment. 3. Discarded. Definition: thrown away because it is no longer wanted or needed. Example: she discarded the old papers after cleaning her desk. 4. Painstaking. Definition: done with great care, time, and attention to every detail. Example: the artist did painstaking work to finish the painting. 5. Droppings. Definition: the waste that comes out of an animal's body. Example: the farmer cleaned the bird droppings from the roof. 6. Afterglow. Definition: a faint light that remains after something bright has happened. In the article, it means the weak light left from the Big Bang. Example: scientists studied the afterglow of the Big Bang to learn about the early universe. 7. Cathode rays. Definition: invisible streams of tiny particles that move inside a special glass tube when electricity passes through it. Example: Röntgen was studying cathode rays when he discovered X-rays. 8. Incision. Definition: a cut made in the body during a medical operation. Example: the doctor made a small incision before removing the tumor. 9. Magnetron. Definition: a machine that produces microwaves, which are used in radar and microwave ovens. Example: the magnetron caused the chocolate bar to melt. 10. Burrs. Definition: small, rough seed cases with tiny hooks that stick to clothes or animal fur. Example: the dog's fur was covered with burrs after the walk. 11. Rigor. Definition: great care, accuracy, and careful work. Example: good science requires rigor and careful testing. 12. Overlook. Definition: to fail to notice or pay attention to something. Example: don't overlook small mistakes in your homework. 13. Mutation. Definition: a change in the genes of a living thing. Example: a mutation can sometimes help a plant survive better. 14. Anomalies. Definition: things that are unusual or different from what is expected. Example: the scientists studied the anomalies in the test results. 15. Look away. Definition: to turn your eyes away from something, or choose not to pay attention to it. Example: she could not look away from the beautiful sunset.
Comprehension questions. 1. What is the main idea of the article? Answer. The article explains that many of the world's greatest scientific discoveries began as unexpected accidents, but became important because curious scientists carefully investigated them. 2. According to the article, what question did successful scientists ask when something unexpected happened? Answer. Instead of asking, "How did this experiment go wrong?" they asked, "Why did this happen?" 3. What did Alexander Fleming notice when he returned from his vacation? He noticed that mold had grown in one of his petri dishes, and the bacteria around the mold had disappeared. 4. Why was Fleming's discovery alone not enough to create penicillin as a medicine? Answer. Because other scientists, including Howard Florey and Ernst Chain, spent years purifying, testing, and producing penicillin, so it could be safely used as medicine. 5. What strange problem did Arno Penzias and Robert Wilson have with their radio antenna? Answer. They kept hearing a mysterious background hiss that would not go away. 6. What was the mysterious hiss later discovered to be? Answer. It was the cosmic microwave background, the faint radiation left over from the Big Bang. 7. How did Wilhelm Conrad Röntgen discover X-rays? Answer. He noticed that a fluorescent screen glowed while he was experimenting with cathode rays, even though it should not have. 8. What happened to Percy Spencer that led to the invention of the microwave oven? Answer. He discovered that the chocolate bar in his pocket had melted while he was testing radar equipment. 9. Why did Viagra become a successful medicine, even though the original experiment failed? Answer. Researchers noticed an unexpected side effect and realized the drug could be used to treat a different medical problem. 10. How did the invention of the Post-it note begin? Answer. A chemist accidentally made a weak glue, and years later another scientist found a useful purpose for it as removable notes. 11. What inspired George de Mestral to invent Velcro? Answer. He examined the tiny hooks on burrs that stuck to his clothes and his dog's fur after a walk. 12. What is Yinmin blue, and how was it discovered? Answer. Yinmin blue is a bright, stable blue pigment that was accidentally discovered while scientists were studying new electronic materials. 13. According to the article, what transforms an accident into a scientific breakthrough? Answer. Careful observation, scientific investigation, repeated testing, and a willingness to ask questions transform an accident into a breakthrough. 14. How has modern science learned to deal with unexpected results? Answer. Modern scientists carefully study unusual results instead of ignoring them. They use advanced technology and careful research to investigate unexpected findings. 15. What lesson does the article teach about mistakes and discoveries? Answer. The article teaches that mistakes can lead to great discoveries if people pay attention, stay curious, and investigate unexpected results instead of ignoring them. Discussion questions, optional. 1. Which accidental discovery do you think changed the world the most? Why? Sample answer. I think penicillin changed the world the most because it has saved millions of lives by treating dangerous bacterial infections. 2. Do you think luck, or hard work is more important in scientific discovery? Explain your answer. Sample answer. I think both are important. Luck may help someone notice something unusual, but hard work is needed to understand it and turn it into a useful discovery. 3. Can mistakes sometimes become opportunities in everyday life? Give an example. Sample answer. Yes. Sometimes making a mistake helps us learn a better way to do something. For example, a student may solve a problem incorrectly at first, but learn a new method by correcting the mistake. 4. Why do you think curiosity is an important quality for scientists? Sample answer. Curiosity helps scientists ask questions, investigate unexpected results, and make new discoveries that improve our understanding of the world. 5. What does Louis Pasteur mean by the quote, "Chance favors the prepared mind"? Sample answer. He means that lucky accidents become important only when knowledgeable and curious people recognize their value and investigate them.